Hey everybody. So here we are with our first lesson on the trig unit. I'm going to let you try this problem on your own, see if you can figure it out, but I will tell you that the correct answer is letter H. So this lesson is going to be 5.1a. It's A because there are actually 3 sections to this. Today we're going to start off with some review. This should be things that you know already. You should know how to use some right triangle trig functions. We've talked about these before. You should be able to set up some trig ratios for angles of a triangle, and we're going to actually talk about the special right triangles. Those might be new. I can't remember if you've seen them before or not, but either way, we'll get it figured out. So here is our sort of like end all be all of right triangle trig. We've got a right triangle here. Notice there are 3 sides all labeled with respect to theta. This is the Greek letter theta, Theta. And we use this a lot in our trig stuff to symbolize an angle. It can be any angle. Generally, it's an angle we don't know what the measure is. So it's sort of like the x, but of angles. And for right now, we'll always do this in degrees. One thing you're going to need to make sure to do for this lesson and the next several lessons is make sure that your calculator is in degrees. So I'm going to pause for a second and tell you how to do that, especially if you're using one of my yellow calculators in the classroom, okay? So once the calculator's on, hit the mode button. That's M-O-D-E. It is right next to the second button. And you'll see a bunch of different things that you can do. If you go down to the third one down, it says radian and then it says degree next to it. Make sure that degree is highlighted. If not, arrow over to degree and push enter. And then that should put your calculator into degrees. To get out of there, you push second mode again, and it clears your screen, okay? So you need to make sure that you are in degrees. We will actually eventually be in radians, and we'll be switching back and forth. But for right now, you need to make sure you're in degrees, especially because the calculus kids are always in radians, and they often switch them, okay? So make sure you have that. Now you can see these 3 trig functions here. We've got sine, which is opposite over hypotenuse. We've got cosine, which is adjacent over hypotenuse. And we've got tangent, which is opposite over adjacent. Now, one of the things, it wasn't a learning target, but one of the things that we're going to focus on, especially in this unit, is using our correct vocabulary. We do not say sin, cos, and tan. We say the correct words for these functions. They are the sine function, the cosine function, and the tangent function, okay? I want to be very clear about that. We use our correct vocabulary here. So when we are finding the sine of theta, we would be taking the opposite over the adjacent. The cosine of theta would be the adjacent over, I'm sorry, I said opposite over adjacent. I meant opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Now, these are all, again, with respect to that theta angle. If we moved to a different angle, and let's say we were considering the alpha angle, the opposite and the adjacent would change because they are with respect to that angle, okay? So I want to be very clear about that. So we're going to set up some trig ratios for our theta. As a general rule, we'll be told what theta is, or at least where it's located, so that we can figure out our trig ratios, okay? So when it says set up the trig ratios, it means to set up all 3. So first we're going to set up our sine. So we're going to write sine of theta. This is important. You do have to write sine theta so that we know we're finding the sine of the angle labeled theta on the triangle. And then that's going to be equal to the opposite side over the hypotenuse side. This is the hypotenuse here. And I'm just going to label the adjacent while I'm at it. Sometimes it's helpful to go through and label those with respect to theta so that you know what is what, okay? So this is going to be 8 over 10, which of course we should reduce if we can to 4 over 5. Then we're going to find the cosine of theta. So we're going to take the adjacent this time over the hypotenuse. The adjacent is 6. The hypotenuse is 10, and that reduces to 3 over 5. And then we're going to take the tangent of theta, which is opposite over adjacent. Whoops. Oh my goodness. Which is 8 over 6, which reduces to 4 over 3. Okay? So when it says set up the trig ratios, what it means is to set up all three of those, again, for the theta that you're given. Let's try another one. This time, notice we've got a radical here. That's okay. We are just going to set up our trig ratios, and they will have a radical in them. So let's start with sine of theta is going to be the opposite, which is here, over the hypotenuse. And then, of course, 1 is the adjacent. So the opposite is 2. The hypotenuse is square root of 5. And we're just going to leave it exactly like that. That is totally fine. Let's do cosine real quick. Cosine is going to be the, adjacent, which is 1, over the hypotenuse, which is square root of 5 again. And then tangent is going to be the opposite over the adjacent, and 2 over 1 is simply 2. Okay? Are you kind of getting the idea of how we're setting these up? Hopefully this, again, is review for you. You've seen this before. Now, what if we don't have all the pieces? So we have the opposite side, which is 5, and we have the adjacent side, which is 3, but we don't have a hypotenuse. And in order to set up sine and cosine, we're going to need a hypotenuse. So that means that we're going to have to do Pythagorean theorem to figure this out. So Pythagorean theorem tells us that the two legs squared and added together is equal to the square of the third side, or the hypotenuse. So we have 9 plus 25 is going to be equal to h squared. And then, of course, that's 34. And then we have to square root. So h, is equal to the square root of 34. That I'm going to make the hypotenuse the square root of 34. And now I can set up my trig ratios. So I'm going to start with sine of theta is equal to the opposite over the hypotenuse. I'm going to try to write here, but my pen is being silly. So 5 over the square root of 34. Well, you can imagine that I wrote it, right? And then the cosine of, there we go. The cosine of theta is going to be equal to the adjacent, which is 3, over the hypotenuse, which is square root of 34. Got to fix this. And then, of course, the tangent of theta is equal to the opposite, which is 5, over the adjacent, which is 3. You're getting the idea, I assume. Let's continue on. This time we're told to solve the triangle. So when it says to solve the triangle, what that means is to find all of the missing pieces. So let's start with the easy one. We can figure out this angle pretty easily up here, this angle C, by simply subtracting 90 and 32 from 180. Well, 180 minus 90 is 90, right? So that means that theta and C are going to add up to be 90. So if we do 90 minus 32, we get 58 degrees. Sounds pretty easy. Now we want to find x and y. So how do we do that? We're going to use our trig functions to do so. So let's start with x, okay? So x would be the adjacent to 32 and y would be the opposite. And I know that adjacent over hypotenuse is cosine. So I'm going to set up a little trig equation here that says the cosine of 32 is equal to x, my adjacent, over 7, my hypotenuse. Now here I'm going to grab my calculator and I'm actually going to solve this out. But this is really a proportion, okay? So I'm cross multiplying here. I'm going to multiply x times 1, which is x, and that's going to be equal to 7 times the cosine of 32. So I'm just going to put in my calculator 7 times the cosine of 32, and I get, and remember we go to 4 digits, right? And then we cut off, oh boy, if I can write here. Well, I get 5.93633666673. So I'm going to round that off to 5.9363, okay? Now let's solve for y. So we're going to solve for y here, and we're going to do kind of the same thing. We're going to set up an equation, and I like to use the numbers that I know. So I don't want to solve for y using the number I just got for x, because what if I did something wrong? What if I messed it up? Or simply because I'm rounding, I might get a little bit of error and it might not be as exact. So I want to use the numbers that I already know, okay? So I'm going to use my 7 and my 32 again. And I wouldn't have to. I suppose I could use 58, but I'm kind of on a roll with 32 here. So I'm going to say that the sine, that the sine of 32 is equal to y over 7. So it's going to look very much like what I just did, except this time I'm going to do sine, and I'm going to solve the same way. So I'm going to cross multiply, and I'm going to get that y is equal to whatever the sine of 32 times 7 is. Well, let's put that in the calculator. 7 times the sine of 32. And this time I get 3.7094. 3.7094. And of course, my pen's not going to write, so you'll just have to take my word for that. Pretend that I wrote it on the screen, okay? 3.7094, and then x was 5.9363, and we've got our answers there. So again, we're going to solve this triangle. Go ahead and do this. Why don't you pause the video, work through it on your own, and then hit play, and you can see if your answers are correct. So your answer for angle C, first of all, should be 60. Okay, and then your answer for C should be, A, let's do A first. A should be 12, and then C should be 6 times the square root of 3, which is 10.3923. So those should be your answers for this triangle. And this actually, the reason that I know exactly that it's the square root of 3 is because this is actually one of those special triangles that I was talking about. This is a 30, 60, 90 triangle, which we're going to look at as one of our special right triangles, okay? So here we have a 30, 60, 90 triangle, and it's always set up with sides that are in proportions to the ones given here. So pause the video for a second, fill this in your notes. You have this triangle there. Fill this in, and then move on to the 45, 45, 90 triangle. So our next triangle is the 45, 45, 90. This one, notice that the two legs are the same and they're both ones, and then the hypotenuse is a square root of 2. Every 45, 45, 90 triangle will be in proportion to this one, meaning that the two legs will be equal, the same length, and then the hypotenuse will be the square root of 2 times whatever those legs are equal to. Let's try a couple and we'll see if we can't solve these out, okay? So here we have a triangle. First of all, this is a 30, 60, 90 triangle. We know that because we're given a 30, or a 60, and we can subtract that from 90 and know that it's obviously 30 degrees, okay? So what we're going to do when we do this is we are going to set up a proportional triangle and use that to find our values of this one. So one of the things you'll notice in the directions, and I didn't put it here and I probably should have, but a lot of times the directions will say be exact. What that means when you're doing this is that you need to be exact in your answer, and your answer should contain that radical value, not the decimal approximation, okay? So let me draw this proportional triangle here. I'm going to try, okay. So my original 30, 60, 90 triangle, and yes, you do need to have this memorized, you will need to know this, is in the proportion with the side 1, 2, and square root of 3. Now, I always remember that the smallest side is across from the smallest angle. So my one side is always going to be across from my 30-degree angle, and my square root of 3 is always going to be next to my 30-degree angle. And that's how that's kind of a little trick, I guess, if you will, of how I remember it. Now, what I'm going to do is I'm going to set up a proportion. So the side 1 compares to the side 5. So I'm going to set 1 over 5. And then I'm going to use these other two sides to find the two missing sides from my triangle. So I'm going to start with the hypotenuse because I think it'll probably be easier. So 1 to 5 is going to be 2 to my hypotenuse. And then I'm just going to solve the proportion. So I'm going to cross multiply. 2 times 5 is 10. 1 times h is h, so h equals 10. Easy enough, right? And then I'm going to set up a proportion. I'm going to use the 1 over 5 again, this time to help me find the side that's next to the 30 that's proportionate to the square root of 3. Now remember, we're trying to be exact here, so our answer should have a square root value in it, probably a square root of 3 value in it, okay? And we're going to set up a proportion the same way. So I'm going to start with, oops. Oh my goodness, I'm having a hard time here. I'm going to start with the 1 over 5, but this time it's going to be equal to the square root of 3 over, what do we want to call this side? Let's call it this, the opposite. I don't really have a reason for doing that. Probably shouldn't use O because it looks like a 0, doesn't it? So I'm going to multiply, let's just make that x. And I'm going to get 1 times x, which is x, is equal to 5 times the square root of 3, which means that the measure of this side is 5 times the square root of 3. Now see how that is exact because I did not find the decimal approximation. Let's try another one here. We've got this triangle. This time we're going to have a 45, 45, 90 triangle. Now the nice thing about this is that we know if we find one leg, we found the other one because they are the same length. So I'm going to draw my other triangle, my special right triangle, and I'm going to set up a proportion. So the square root of 2 goes with 10, and that's going to be equal to 1 over x. And again, when I solve for x, I will be finding both of the legs because they are the same length. This is an isosceles triangle. So when I multiply, I get x times the square root of 2 is equal to 10. Well, if this was just a regular 2, I would divide, right? So I'm going to do the same thing, and I get x is equal to 10 over the square root of 2. So this side over here is 10 over the square root of 2, and this side on the bottom is 10 over the square root of 2. And that is all you need to know for solving those special right triangles. So anytime you're dealing with a special right triangle, your answer should be exact, meaning that you are leaving it in radical form. You are not finding the decimal approximation. Some of those other triangles where it's not either a 30, 60, 90 or a 45, 45, 90, those are okay to find the decimal approximation for, all right? I hope you understand the difference. These triangles are super important because we're going to use them a lot in this unit. So I'm hoping that you're doing okay with finding your trig ratios. Remember, that means setting up sine, cosine, and tangent for whatever theta you're asked to find using the triangle. I hope you're feeling okay using special triangles. Those are the 30, 60, 90, and 45, 45, 90. And then being able to solve a triangle, which really means find the missing pieces. Whatever triangle you're given, that you can find the missing pieces for. I hope you're feeling okay with this. Be happy to answer any questions that you have. Let me know, and we will chat about this more in our next lesson.